Hello friends, in this video I am going to teach you the concept of Venn diagrams, and we will be solving the problems based on set theory using Venn diagrams. So first of all, what are Venn diagrams? Venn diagrams. So what are Venn diagrams? So Venn diagrams are the graphical notation to represent different sets in a sample space. So they are actually closed shapes, simple closed shapes to represent different sets. So let us take an example. In Venn diagram representation, the sample space or the collection of all the sets is represented by a rectangle. Sample space. So what is a sample space? Sample space is the collection of all the possible finite sets in a problem. So the collection of all finite sets in a problem is denoted by the sample space, which is a rectangle. Now let us consider set A, which is in the problem. So set A is represented by a circle. Remember, the sample space is represented by a rectangle and all the sets are represented by circles. So the sample the set A is represented by a circle, and similarly a different set B, is represented by another circle. Similarly, we can have a high number of sets in the sample space. So I'm going with 2 to make it simpler. So now, what are these areas representing in this diagram? I will show you that. So first of all, the sample space, as you know, I have told you, is the collection of different sets. Now this area, the area under A, let me shade it. This area is all, this area represents all the data in the set A, and similarly this area right here represents all the elements of the set B. Now as you can see, there is a common area between A and B. So what does it represent? So this area, which is common here, represents the elements which are present in both set A and B. Remember, here the key word is AND. So AND, A and B. A and B. So the word AND is in mathematics represented by this symbol, this intersection symbol. So A intersection B represents the elements which are both in A and B. Now elements of A, elements of B. Now what is the left out area? So this left out area, all this area and the area here, this area represents, this whole area, white area left out, is the elements which are neither in A or in B. So let them be represented by C. Not in A and B. they are not in A and B, but they are in the sample space. So now one more thing, the area under both these circles, the area which is covered by both these circles, which is, let me shade it out for you. This area, what does it represent? So it represents the elements which are common, not common. This represents the elements which are present both in it represents the elements which are present in either A or present in either B. So A or B, here the keyword is OR. So OR is represented by the union symbol. So this area is represented by A union B. Now we will solve an example based on this Venn diagram representation. So let us consider a class of 50 students. Let us take a class of 50 students in which 25 opted for course A, 25 opted for course B, 15 opted for neither course A or B. So let this be represented by the set C. These are all these are all sets. So A represents the set A represents the number of students who have opted for course A. Set B represents the number of students who have opted course B, and set C represents the students who have neither opted for course A or B. Now the sample space is 50. Let's draw the Venn diagram for this. Now this is the set A, this is set B, this is the sample space. So now sample space is 50. So now we have to find the students who have opted for both course A and B. So we have to find students who opted both A and B. So here the keyword is AND, so we have to find A intersection B. So as you can see, students who opted both A and B, which is elements which are common in A as well as B, which is this area. So this is A intersection B. So how do we find it? So as we can see, the sample space is sum of areas in it. So it is A plus B plus C. C is this area, the white area outside A and B, minus A intersection B. Now how do I arrive at this equation? How did I arrive at this equation? So the sample space is actually the sum of the areas it contains. So as you can see, the sample space is sum of A plus B. Now there is a common area which is represented, which is repeated in both the sets. So A plus B minus that common area. We have to count that common area only once. So A plus B minus A intersection B plus C. So putting the values, we get 50 is equal to 25 plus 25 plus 15 minus A intersection B, which gives us A intersection B as 15. So there are 15 students who have opted both A and B. So this is how we solve the problems based on set theory using Venn diagram. Stay tuned.